Okay, now we'll speak about the second part of section 10.3. It will be a short lecture, not a long one. I mean, the completion is just a small lecture. Here it says find a polar coordinate for this curve in Cartesian system. So replace x by r cosine theta and y by r sine theta. We will get r squared cosine squared of theta minus r squared sine squared of theta is equal to 4. We take r squared common factor, so we will get cosine squared theta minus sine squared of theta is equal to 4. So that will be r squared cosine 2 theta is equal to 4. That is actually the equation, but we can reduce it to say r squared is 4 over cosine 2 theta, which means r is equal to r squared is equal to 4 times secant 2 theta. So that will be the simplest form, but that is also true for polar coordinate. For graphing r is equal to 1 minus cosine theta, we have two methods. First method is using the table, which means we have to know period. It's 2 pi divided by b, but b is 1, and delta is equal to pi over 4, so it will be pi over 2. So our theta r values, we will select 0, then delta, which is pi over 2, then pi, then 3 pi over 2, and we end up with 2 pi. If I put theta is 0, it will be cosine 0 is 1. Cosine 0 is 1, so 1 minus 1 will be 0. If I put pi over 2, that will be 0, so that will be 1. If I put pi, it will be cosine pi minus 1, so minus of minus 1, it's 1 plus 1, which is 2. At 3 pi over 2, it will be 0, so 0 plus 1. If it is 2 pi, it will be 1. 1 minus 1 is 0. So if we use table, what does that mean? When theta is 0, this is r and theta. If theta is 0, the radius is 0. If theta is pi over 2, the radius is 1. So it goes from 0 to 1. Then at pi over at 2 pi, at pi, it will be, this is 1, we said, this is 2, so it will go that way. Okay, and at 3 pi over 2, it will go back to 1. Angle 3 pi over 2, it will go to 1. Then from 3 pi over 2 to 2 pi, it will go back to 0. So that's the graph using the points. Or you can see the feeling. I said here, using this table, it will say if you have y is equal to a plus a cosine theta, it will be right. And if you have a minus a cosine theta, it will be left. Apple, it's apple, but right, apple and left. If it is a plus a sine theta, it will be apple, but it is upward, and y equals to a minus a sine theta, it will be apple here up, and here is apple down. If you just have a feeling, of course, a means both numbers are the same. Okay, so if I go to Dismas, for example, just to show you, to get the idea, if I go to Dismas says the following. If you have R, okay, R is equal to 1 minus cosine the angle theta. You see it's apple in the left. And if we say plus, it will be apple on the right. If I say instead of cosine sine, it will be apple, but it is upward. And if it is minus, it's apple downward. Okay, so from here, if I use this method, which is using the table, since I have r is equal to 1 minus cosine theta, so I know this represent apple on the left. So all what I will say here, it will have the shape of apple in the left, and I know it will start from 0 when it is 0, and it will go here to 1, then it will go there. Let me say this is, and that will be again 1, so it will be, that will be 2, so it will be, it's apple of this shape. Okay, so either using the table or simply use points. Here we have to take care of the points. When we use table, here it's not easy, but not difficult as well, but it will take time. Here, our delta, if we draw y equals to cosine 4x, we have period 2 pi divided by 4, which is pi over 2. And we have delta period divided by 4, so we will get pi over 8. So to complete a cycle, a circle, a complete revolution, we will have, I am graphing now y is equal to only cosine for x. So if I choose x and get values of y, 0, then pi over 8, then 2 pi over 8, which is pi over 4, 3 pi over 8, and 4 pi over 8, which is pi over 2, that would be one period. So at 0, if we go look to the unit circle, when I substitute 0, I should get 1, 0, this is 0, 1, minus 1, 0, 0, and minus 1. So we are speaking about cosine, so it will be the x coordinate, so it will be 1, then 0, then minus 1, then 0, then plus 1. So if I continue, the values will continue. This is 0 pi over 8, pi over 4, 3 pi over 4, pi over 2. Okay, then which is 4 pi over 8, 5 pi over 8, 6 pi over 8, 6 pi over 8 will be 3 pi over 2, 7 pi over 8, and 8 pi over 8, which is pi. So I'll get here 1, 0, minus 1, 0, 1. It will be 0. So we said 1, then 0, then minus 1, then 0, then it will be 1. So if I draw this one in XY coordinate system, so let me say this is x-axis, that's y-axis. So I'll say this is pi over 8. This is 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8. So pi over 8, 2 pi over 8, and so on, 3, 4 pi over 8, which is pi over 2, 6 pi over 8, 7 pi over 8, and pi. And we can continue. This is 8 pi, this will be 9 pi over 8, 10 pi over 8, 11 pi over 8, 12 pi over 8, and so on. So this will be 8, 9, 10, 11. This will be here. Okay, so at pi over 8 we get 1. At 0 it's 1. At pi over 8 is 0. Then minus 1, 0. Then it will be 1. then 0, then minus 1, 0, then 1, 0, and minus 1, 0, then 1, then 0, and so on. So that should be the graph, supposed to be. This is the graph. Okay, but since r squared, so we will not consider the minus, so we will get only that one, then 3 pi over 8 until 5 pi over 8, then negative, we'll skip it, we'll get that one, we'll skip that one, we'll get that one, and so on. Now, when I want to go to r and theta, how like? When I go from here to r and theta, we will say this is r4 and pi over 8, and that will be another pi over 8. So if we have this one also, okay, now same story here. If I have that one pi over 4, and that will be, when we have it, it will be pi over 8. When we have that one, it will be pi over 8. Now, see what will happen. When x is 0, sorry, from here, our radius was 1. When theta is 0, radius is 1. So we will say that is 1. When theta is 0, the radius is 1. When it goes to pi over 8, it goes to 0. So it will be this way. Okay? Now, then that's what we have from here. Then we said if it is a 3 pi over 8, this is pi over 8, this is 2 pi over 8, that is a 3 pi over 8. When it is a 3 pi over 8, it was 0. But when it goes to pi over 2, which is this one, it becomes 1 again, which is this part. Then, so we get that one. From pi over 2 to 5 pi over 8. This is 4 pi over 8, this is 5 pi over 8. So at 5 pi, from pi over 2, it's 1. It will go to 5 pi over 8, it will be 0. Now, then we get that one. From 7 pi over 8, this is 5. Okay, this is 6. So this is 7 pi over 8. It says at 7 pi over 8, it was 0. And then when it goes to pi, it will be 1. So that will be the part. That is this one. From 7 pi over 8, it was 0. At pi, it becomes 1. Now, at pi, it's 1. But when it reaches, this is 8 pi over 8. This is 9 pi over 8. At 9 pi over 8, it will be back to what? 0, which is this one. Now, so we get that one. Now that's negative, we don't need it. This is 9, this is 10, that will be 11 pi over 8. And then 12 pi over 8, 12 pi over 8, which we say divide by 4, it will be 3 pi over 4. Okay, now here it says if it is 11 pi over 8, this is 9, this is 10, that's 11 pi over 8. 11 pi over 8, at 11 pi over 8 it was 0, and it will go to, at 11 pi over 8 it is 0, and we said here 12 pi over 8, we said divide by 4, it will be 3, divided by 4 is 2, that's a 3 pi over 2, it will become 1, so it will be from 0 going to 1, and then from that is a 3 pi over 4, sorry, 3 pi over 2. Oh, I should not touch that one. Okay, go back. Again, go back. Okay, view full screen. So we said we reach 11 pi over 8. At 11 pi over 8 it was 0, and at 3 pi over 2, that's a 3 pi over 2, it becomes 1. Then at 3 pi over 2 it's 1. At 3 pi over 2, this will be 11 pi over 8. Yeah, 12 pi over 8, which is 3 pi over 2, it's 1. Then it will go to 13. This is 12. That this will be 13 pi over 8. Okay, so it will be back to 0. Now we can continue actually the graph, because R, if we replace theta by minus theta, it is symmetric around bool, around Bowler, sorry, Bowler, and also it is symmetric about bool. So it's symmetric about Bowler and symmetric about bool. So that will be our graph. Now, if I want to use instead of that one, here, this is 2 theta. What will happen if I have 4 theta? If I have 2 theta, it will be 2. If I have 4 theta, it will be that one. And if this is 4 theta, it will be that one. So it's according to the number here. If I have 2 theta, I will have only 2 leaves. If I have 4 theta, I will have 4 leaves, and it will be symmetric about the polar and about the origin. Here it will be symmetric only about the origin. So what we will do, I will show you using this one. If I have, what was our equation? R squared. We have R squared, as I said, R squared, we cannot write it R squared. We can say R is equal to square root of cosine. Look here, Shabab. I will write first 2 theta. And you can see how it looks like. If I change 2 to 4, what will happen? Becomes 4. If I put 8, I will get 8. If I get 16, I will get 16. And all the time it is symmetric about the polar axis, which is this axis, and also symmetric about the bool, which is the origin. So what we are concerning on now, it's only 4 theta, so we will have 4 leaves, symmetric about origin and symmetric about the bool. Okay, if I have sine, what will happen in the sine? If I have 4, it will be again 4 leaves, but symmetric about the origin only. Okay, so if we are using this formula, if it is 4 theta, it will be 4 leaves. If it is 4 theta for cosine, it will be 4 leaves. So using the table, we get again. So all what we need to say, if we are using method 2, we will say method 2, since theta, since our angle is 4 theta, so it has 4 leaves, symmetric about polar axis and the bool, which is the origin. This means origin. So if this is our, we are relying on the formula, I mean in that formula, so we will say I have 4 leaves. This is the first leaf, which is symmetric about origin, and That's another leaf, and it will be symmetric about the bool and the origin. So here I am relying in the table, and here I am relying in the points. You can choose any method you like, but both of them will be correct. So let's save it and go away from here. So I'll take this one out. We'll go to close it. I think it should be smooth. This is leaf.